With example 28, we see a situation that is quite common on the AP exam and in textbooks as well. It's really deciding or really showing which students understand this concept of the chain rule. There are no specific formulas for the functions. We're given the fact that f and g are continuous and differentiable functions. But that's all we're told about them, with the exception of a couple of values. We're told that f of 1 is 3, f prime of 1 is negative 2, g prime of 1 is 4, and g prime of 3 is equal to 5. Okay, that's all we're told about them. We have no idea if it's x squared plus 4x plus 2 or anything like that, cosine, who knows. We have no idea what the specific formulas are. The test tape makers love to do this type of thing. Okay, they then give us another function, h. H is a composite function. It's g of f of x. And they ask, what is h prime of 1? Okay, so as the calculus student here, we have to realize that because h is a composite function, when we derive this side, when we find h prime, and we derive this side, we have to use the chain rule. This is where we see Newton's notation more than we see Leibniz's notation, which is why I'm kind of pushing in that direction for a situation like this. So let's go ahead and find h prime of 1. Before we can find h prime of 1, we need h prime of x. So let's get that. H prime of x, we see we have g of f of x. The outer function is g, the inner function is f. So using our chain rule, which we have to use, this is not a product, we can't use the product rule, this is not a regular derivative, we can't just do g prime f prime, nope. It's a composite function, which means we have to use the chain rule. And the chain rule says, derive the outer function, g is the outer one, so we derive it, keep the inner function. So we're going to take g prime of f of x. Right? Then multiply this term by the derivative of the inner function. So times f of x is the inner function, so the derivative of f will be f prime. Okay? So this is our derivative of h right here. It's our chain rule, it's what you've seen on previous pages. The f's and g's have been swapped around because I made g the outer function, and quite often f is displayed as the outer function, but it doesn't have to be. Okay? So now let's find h prime of 1. Okay, so that's going to be g prime of f of 1 times f prime of 1. All I've done is I've replaced the x's with 1's in all three cases. And that allows us to go to our data up there. We need f of 1. We're told that f of 1 is 3. So this now becomes g prime of 3 times f prime of 1. So in fact, we don't need all of the data here. All right, we've used a little bit of it. We're going to do some of the data, though, we're not actually going to need. G prime of 3, that's equal to 5. We need that one. Times f prime of 1, which is negative 2. So we need that one. All right, this g prime of 1 doesn't help us at all. And in problems like this, it's quite possible that they will give you extra information. We just got to learn which information we need, which information we don't need. All right, so we end up here with 5 times negative 2, which means that h prime of 1 will be equal to negative 10. That is our derivative of h at 1.